Hello and welcome back to the course on blockchain. Today we're talking about HD wallets, or I'm going to try pronounce this, hierarchically deterministic wallets. That's what we're talking about today. Let's have a look. So here we've got our whole setup of private key, public key, message signature verification function, and address. And so we already know how all of this works. Won't go through that again. But the question here is about privacy. That's what we're going to address today. So we know that Bitcoin and blockchains in general are meant to be, or cryptocurrencies are meant to be anonymous, or not exactly anonymous, pseudonymous. So like pseudonymous. So as long as nobody knows who this private key is attached to, they don't know who you are, right? So they're not completely anonymous, because if one day somebody finds out who's behind the private key, then they will know exactly everything about how you've been transacting. So like your private key acts as a barrier, or as like a avatar, or a pseudonym, pseudonym, I guess, for you. And yeah, and so that's how they're meant to be. That people are not supposed to find out who you are based on your transactions. They're not supposed to be able to just monitor what you're doing and things like that. But if we think about it this way, that every time you want somebody to send you money, you have to give them your address. And every time you send someone money, your public key ends up getting attached to that transaction. And so somebody can just go through the whole blockchain network and pick up every time your address or public key pops up, and they can start observing things. They won't know who exactly this address belongs to or who it's transacting with, but they will see patterns. They'll see that this address keeps receiving money from this address, and the public key is being used to send money to these 3-5 addresses, or so on. And they can create different patterns, or see different patterns of what's going on. And and maybe at one point somebody might figure out that one of the addresses where you use your public key to buy stuff is like a pizza shop near your city, and they might be able to track how often you go there, and they might predict when you're going to be there and things like that. And even though that sounds a little bit paranoid, it's actually quite a big concern. If a network promises that things there's going to be privacy in the network, then there has to be privacy in the network, right? Rather than these kind of patterns people being able to establish them. And so what is the solution? Well, up until some point in time, people would do the following thing. If people really wanted privacy, they would create multiple private keys and generate public keys from each one and an address from each one, and then you'd use a private or public key or an address for certain things, and then for other things you use a different public key or a different address. Or if you want real privacy, you just all the time you just generate a new public key and new address every single time. And thankfully they're huge, large numbers, so there's almost unlimited. We can think that there's an unlimited number of these public keys and addresses. We can generate as many as we want, but it becomes very tedious keeping track of things and also maintaining these private keys safe and secure. And so knowing where they're written down and things like that. And so after a point in time, Bitcoin introduced a improvement called BIP 32. It's called BIP stands for Bitcoin Improvement Proposal. And in that proposal, they propose exactly what we're talking about today, hierarchically deterministic wallets. So what is that? Well, with an HD wallet, what you get is a master private key. That's your main thing that you get first. And then from that master private key, then only is a private key generated from the master private key. And then the private key is used to generate a public key, and the public key is used to generate the address. So this part is kept secure. So you shouldn't tell anybody your master private key or your private key. Then what happens is, and also same thing here, address is something you can share freely. Public key, preferably not to receive transactions on your public key, better receive them on your address, as we discussed before. But now if you want more privacy, if you need more public keys and addresses, all that needs to happen is your master private key can generate more of them by simply, you just your wallet, what it'll do for you is it'll add a 1 to your master private key, and then it'll generate a whole new set, because it's using the hash function again. So here it's using the hash function. So basically once you add +1, bam, it's a completely different number eventually, and you get a new set like that. And so you can add +2, add +3, and so on. So you can generate as many private key, public key addresses as you want, as long as you just have access to this master private key. And this is all deterministic, so you can just regenerate this at any point in time. Like, there's no need to remember all of these. You just, the wallets will remember for you the numbers that it used, and that's it. And you will be able to get your private key. So all you need is the master private key. So that's the structure. And so how is this advantageous? First of all, it's very useful for wallets. They do this automatically when you need to receive money or when you need to send money. They put in different public keys and addresses all the time. So and they just generate new ones, and like that way nobody can ever track this what's going on, where money is going in, where money is coming out. Also, this is a interesting idea for an organization. So if an organization is going to use Bitcoin or cryptocurrency for their services or products, for just running their business, what they could do is they could have like the main, like the director of finance have the master private key, and then each department have a separate private key. And the beauty of that is that with the master private key, you can always go into the blockchain and you can always find out everything that the organization has spent, all of the transactions that came from any of these private keys, anything that happened, like in this. That's why it's called a hierarchically deterministic wallet. It's got this hierarchy. So if you have the master private key and you go into the blockchain, you can find all the transactions associated with any of these branches. But if you only have the private key, so if this is, let's say, the Division 1, Division 2, Division 3, Division 4, well, Division 1 can only go in the blockchain and they can only ever find their transactions, because they can only generate their public key and their address that's linked to that comes from their private key. They can never see what Division 2 has been doing, Division 3, Division 4. So that's another great advantage of having this master private key. So you have more oversight of the organization. That's for businesses. And another thing that was suggested as well in BIP 32 is a master public key. In fact, this slide is a little bit wrong. The master public key shouldn't necessarily be inside this in this square. It should be outside. So this square should finish here. So it's not something you have to keep secure, the master public key. And so the master public key, what is that used for? Well, the master public key you cannot get the private keys from the master public key, but the master public key can recreate any of the public keys here. So you cannot, so basically it's kind of like skipping the step. You can only go through here. And what would you use the master public key? Well, you would use the master public key in order to go and you would give it to somebody like an auditor, or somebody who doesn't need to be able to send transactions. Remember, we need the private key to send money, and the public key is used for verification, and the address is used for receiving money. So we definitely need the private key to send funds to somebody else, and therefore an auditor, somebody who's auditing the organization, they don't need to be able to send money. But at the same time, they need access to the public keys to go through the blockchain and understand where funds have been sent, because we can see that through the public keys, and where funds have been received, we can see that through the addresses, which can be generated from the public keys. So a pretty interesting setup, very powerful. So that was what was proposed. I'm going to, at the end of this tutorial, I'm going to link to a interesting article by Vitalik Buterin, kind of critiquing this setup, because there was like a flaw. I'm not sure if the flaw is still there, but we'll talk about that in a second. And so this is the hierarchically deterministic wallets approach, and that's what you probably, like, you will often encounter if you're ever using Bitcoin for yourself, you'll encounter a hierarchically deterministic wallet, and you'll see that if you actually go through the transactions, you'll see that they're using different addresses, or different public keys are attached to those addresses, and the wallet does that for you all in the background. You don't have to worry about it. But this is what happens, as they say, under the hood. And so let's have a look at one more thing that I wanted to mention today, is that this master private key, how do you keep it safe. So very often, well, you obviously like write it down or save it somewhere, but very often the wallet provider will prompt you to create a mnemonic. They will give you a mnemonic to remember. It's 12 words that they ask you to write down with a pen on a paper and keep it somewhere safe, like in a safe. And because that mnemonic is what generates your master private key, that's how you can recreate it. And there's a reason to the mnemonic. Is because there's certain number of words in the English language, and when you take 12 of them, then the number of possible combinations is so large that it's again very unlikely that two people will have the same mnemonic and therefore the same master private key. But basically, if you ever start a wallet and you see this, that they ask you to come up with a mnemonic, that's the reason they're asking you to do this, is because from that mnemonic, if you write it down on paper, and then if like you lose your password or their servers get destroyed or something like that, and that master private key is lost, you can always take that mnemonic, and using that same algorithm, you can generate your master private key, and from your master private key, you can generate all the private keys, all the public keys, all the addresses. Everything can be restored completely just from this one mnemonic. So if you ever encounter that, that's the reason why they're asking you to do this, and it can be a good idea. But you have to keep that paper safe, because anybody else who has that paper can also just restore your master private key and take control of it. So there we go. That's how HD wallets work. And if you'd like to learn more, then check out the article by Vitalik Buterin. It's called Deterministic Wallets, Their Advantages and Their Understated Flaws. So it's a great description. It's got some great analogies there about how to think about these wallets. This part about the understated flaws, that is him referring to what is it called? Like a bug or a vulnerability where if you share the public master public key and the private keys, the child private keys, not the master private key, but the child private keys, if you share them at the same time, so if somebody gets their hands on both at the same time, for instance, one of the leaders of the departments has a child private key, and also it has the private key, one of those that you generate, those extra ones, the red ones that we saw, and also gets their hands on the one that the auditor gets, then they might be able to break the system and find out the master private key. But bear in mind, this is an old article. I'm not a developer, and unfortunately I don't know if that vulnerability has been fixed, so take it with a grain of salt. But the rest of the information in the article is quite great if you want to understand HD wallets even better. And on that note, I hope you enjoyed today's tutorial. I look forward to seeing you back here next time. And until then, enjoy blockchains.